In the last video, we talked about custom cross-validation. In this video, we will talk about custom loss functions. So as we know, our loss function is our main feedback mechanism for our model. It's what we are trying to minimize, and it's what we use to guide our model to the best possible behavior for our given problem. If we are doing something like classification, we might choose log loss or Brier score. If we have a regression problem, we might use something along the lines of negative mean squared error when we are choosing our loss function. One other thing we can do is actually create our own loss function. So let's say that there's a certain type of error that we care more about for our given problem. We can create a custom loss function that will take that into account. So here's a very simple example. I'm able to just create a very simple function like this. Kind of as a given for these types of functions, it will take yTrue and yPred, and then there's a series of keyword arguments we can pass into it, and I'll get into how we do that here in a bit. But in this case, it takes something called over penalty. Again, this is very simple. If we were doing something that was tethered to a more challenging data set as opposed to a toy data set that I load in later, we may want to make this a little bit more sophisticated, but I still think this provides a fine example. Again, this just does something very simple. It finds the absolute error, then it determines, is this an over prediction? And in that case, that will create a column called over prediction. And then more or less what we do is we define our loss as the absolute error that is given a magnification if the over penalty is on. So if we have over predicted, we're going to magnify the error. And then our score is just the mean of this loss column. Again, this is just an example to show you how it works, but this might be applicable in a situation where we, of course, will be okay with errors. All models make errors, but we would rather those errors to be under predictions as opposed to over predictions. So there could be cases where we absolutely don't want to miss on the high side. We would rather miss on the low side based on how we're actually going to use the model. So let's see how this actually gets applied. So I just load in a toy data set. I do kind of our classic train test split, and then I can use this make score magic, if you will, from scikit-learn, which will take my function, something called greater is better. We'll show the documentation for that, and then the keyword argument of over penalty. So let me actually pop open the documentation for this. So again, this takes the score function, which is a callable, as you saw. Greater is better. So whether score function is a score function meaning high is good, or a loss function meaning low is good. So again, are we trying to minimize this? Are we trying to maximize this? In this case, we set this to false in our use case because lower is better. And then again, we pass in our over penalty as our keyword argument into this. I'll get more into the construction of the actual model later, but instead of using grid search or randomized search, we're using hyperopt, which is a more intelligent way to optimize our hyperparameters in many cases. Could be overkill for very simple use cases, but I often use hyperopt as one of my go-tos. So we'll actually see what happens in this function as a little preview. So this takes a handful of arguments that you can see, and then most importantly for this specific video, it takes in our CV score. So let me pop open this function and let's just see where that gets applied. That just gets applied right here in the cross-val score from scikit-learn. So under the hood with hyperopt, we're using some scikit-learn functionality. Again, we'll get more into this in an additional video, but if we were just doing something along the lines of a straight cross-validation score that was not wrapped by hyperopt, or if we were using grid search or randomized search, this CV score that we have built would work in those as well. So I will go ahead and run this model. And we can see that it trains, so it produces a pickle file here, and then a CSV of cross-validation scores, and we can see that these are not nulls. These are actually populated with actual numbers, so this model did train appropriately using our custom loss function. So again, there could be cases where we want to do something that is not just an off-the-shelf loss function that we need our model to be aware of certain types of errors, and we want to guide our model away from those as much as possible and take that behavior into account as we're optimizing hyperparameters. So this is really, I found, a great way to adapt models to specific business use cases and really kind of bring in business logic. So again, we just did something very simple here where if it was an over prediction, we would give an additional error and weight that more. So this would guide the model to, when it makes errors, hopefully more than likely those would be under predictions as opposed to over predictions. So again, experiment with this, play with this, but this is a really useful way for you to bring in subject matter expertise and business logic into actually training and optimizing your machine learning model for specific use cases.